Hello, everyone. Good evening for all of you. Let's start now the revision. Hello, everyone. Good evening for all of you. Today, we will continue our free sessions for the revision of the KAPS exam, the coming one, with the second session. Today, we will discuss about 20 questions related to the exam from different topics, either calculation, pharmacology, pharmaceutics, chemistry, and so on. So let us see the questions. And as usual, I will make all of you mute. And at any time when you have any question, please ask about it. Then we can open the discussion after we finish this session. Okay. The first question today, you are to prepare 750 milligrams of medication in 75 milliliters of for infusion over 30 minutes using 10 drop sets. How many drops per minute will that be? Is it 20, 25, 30, or 10? How can we solve a question like this? Firstly, you should know what is the meaning of 10 drop set. This means that this dropper produce 10 drops for each 1 milliliter. Okay, or to produce 1 milliliter, we need to drop the dropper to give 10 drops. This is the 10 drop set. Okay. Here we have the rate of infusion by milliliter per minute. So you'll find that every 75 milliliters injected through 30 minutes. We need to know how many milliliter per 1 minute, because the answer should be by minute or per minute. So every 2.5 milliliter injected or infused within 1 minute. Okay. Then the dropper here saying that every 10 drops equivalent to 1 milliliter. So 2.5 milliliters equivalent to how many drops? This is the question. By crisscross, you will get that 25 drops every 1 minute to give the actual or the right dose. Okay. Let us see the next question. Low molecular weight compounds that act as immunogen after chemically complexing to larger molecule or cell surface is called. What we call this molecule? A small molecule will give an immunological reaction when it is attached to a bigger one. So here we have a small molecule. By itself, it will not cause anything. But if it is attached to a protein or a large molecule, it will give an immune response.
Hepton?
Yes, it is hapten. This is the right expression for this small molecule. So the choices, hapten, haploid, diploid, or immunogen, it is hapten. The next one. The following is a product. Let us see the choices. Ethynyl estradiol, hydrocortisone, spironolactone, or testosterone. Which of them is called a prodrug? Regarding to those choices, it is ethynyl estradiol. What is the meaning of prodrug? Prodrug is a drug that have no efficacy or pharmacological activity by itself, but it needs to be metabolized in our body to give the active form or to give the active metabolite. Okay, so regarding to those choices, ethynyl estradiol is the right answer. The following structure non-superimposable on its mirror image shows R and S configuration. This optical isomerism is defined as which of the following?
Enantiomers.
Let us see how can we judge and how can we choose. Diastereomers, optical isomers, enantiomers, or geometrical isomers. Firstly, they are saying that both of them are isomers to each other. One of them is R and the other is S. So let us see. Firstly, how many chiral carbons present? There is one chiral center. One chiral center. They are mirror image to each other. And they are not superimposed. Not superimposed. Okay. Are they optically active or not? They are optically active. How can we know? There is a rule, we can follow it to know if the compound is an optically active compound or not. The first thing, it should contain at least one chiral center. Okay, it should contain at least one chiral center. The second thing, if number of chiral centers is odd number, either 1, 3, 5, 7, and so on. Directly, this compound is optically active. Directly, you can consider it as optically active. While if the number is even number, 2, 4, 6, 8, and so on, here we should make another thing. We should look into the compound. If the upper part and lower part are mirror image to each other, so you should bend the compound over itself. If the upper part and lower part are a mirror image to each other, then it is not optically active, or we call it optically inactive. Like the following. Here we have tartaric acid. Okay. If you bend this tartaric acid over itself, what you will see? The upper part and lower part are mirror image to each other. So in this case, it is optically inactive. While the following, we have the same tartaric acid, but the upper part and lower part are not mirror image to each other like this. If you bend the upper part and lower part, they are not mirror image. So in this case, this form or this isomer of tartaric acid is optically active. Okay? What we call this isomer? It is meso compound. So the meso compound is optically inactive compound. Okay? This is how can we know if the structure or if the isomer optically active or not. For those two isomers, they are containing only one chiral center, so they are optically active. If you achieve those 4 characters, directly the two isomers are called enantiomers. So the right answer here is enantiomers. Okay? But What about the diastereomers? For diastereomers, the first character, at least 2 chiral centers. So if we have a compound containing 2 chiral centers, then we can say is it diastereomers or enantiomers, but only 1 chiral center, so it is enantiomer, not diastereomer. Okay, for enantiomers, it should contain at least 1 chiral centers, while for diastereomers, it should contain at least 2 chiral centers. For diastereomers, it should be not mirror image. To be diastereomer, it should not be mirror image to each other. It should not be superimposed, not superimposed, and it should be optically active. Okay, so those are the 4 characters of diastereomers, while those are the 4 characters of enantiomers. Yes, Shrenik, please ask.
Yeah, sir. Only R and S configuration only comes in enantiomer, right?
No, it may be diastereomers also. What is the R and S? What is the meaning of R and S?
R means the rotate the clockwise, and S means anti-clockwise.
This means anti-clockwise. What is the meaning of this rotation? Or why we put this configuration R and S? R and S represent the arrangement of the functional group around the chiral center. Okay, R and S means the arrangement of the functional group which are surrounding the chiral centers. This arrangement, is it clockwise or anti-clockwise? If the arrangement is clockwise, so it is R, we'll take R configuration. While if it is anti-clockwise, so it is S configuration. Okay, this is the meaning of R and S. Maybe enantiomers, maybe diastereomers.
Okay, sir.
The next question. Which of the following is the least cardiotoxic insane? This one repeated several times in the last couple of exams. Which is the least cardiotoxic? Naproxen, meloxicam, celecoxib, or diclofenac? Directly. The cardiotoxic NSAIDs, you should take care about the coxib family, celecoxib, ralicoxib, or any drug related to coxib family. The least one is naproxen. Naproxen is the least one for cardiac toxicity. The last part of small intestine is called fundus. No, it is a part of stomach. Ileum, duodenum, or jejunum. Of course, it is the ileum. It is the ileum. Find the ratio of ionized to unionized drug species at pH 7 and pKa 5. This is a calculation problem. How can we find the ratio? We need the ratio between ionized to unionized parts. How can we solve this one? By using of the equation or the formula of Anderson-Haselbach equation, which saying that pH equal pKa plus log ionized over the unionized. So we need to define this ratio. What is this ratio? So let us solve the formula. pH equals 7 and the pKa equal 5. The log ionized over unionized equal 2. This means that it is, or the ionized over unionized equal 100 to 1. And this is the ratio. Unionized part is 1 and ionized part is 100. So it is 100 to 1. Does this drug absorb it well or not absorb it, or very low absorption? Which part will be absorbed, the ionized or the unionized?
Ionized.
The unionized will be absorbed, while ionized part not absorbed. Okay, so when we see this ratio, this means that this drug have a very little absorption rate. When we compare the parts of the drug, we have 100 parts of the drug is in ionized form, while one part only in unionized form. So the absorption will be for this one part, a very little absorption rate for this. Okay? So if the question changed to ask, does this drug absorb it well or not absorb it? Now we can say that this drug have a very little absorption. Again, for which part? For absorption or for the solving the equation? For the absorption. For any drug, to be absorbed, it should be in the following formula. Either non-polar lipophilic, or it should be lipid soluble, unionized. Those are the formula of the drug to be absorbed or diffused from the membranes. Otherwise, the polar one, the water soluble, and the ionized drugs, they will not pass through the membranes or will not absorb. Okay? According to the calculation that we have here, we saw that the ionized part in comparison to unionized part, we have 100 parts of the drug is in the form of ionized, and only one part in the form of ionized. Okay, this means that this drug had a very little absorption rate. Is it clear or not? Okay. Let us do it with the opposite figures. It is this, and do it by the opposite figure. How? Suppose that the pH, the pH equal 5 and the pKa equal 7. What is the calculation in this case? 5 equal 7 plus log the ionized over unionized. So the log value of ionized over unionized equal -2. In this case, the ratio will be ionized over unionized equal 1/100, or the unionized part will be 100 times ionized part. A very good absorption rate for this drug. What is the conclusion of that? When you put acidic drug in less acidic or basic medium, we have less absorption. But when we put acidic drug in more acidic medium, here we have more absorption. But if we put acidic drug in similar pH of its pKa, what we will have? 50% absorption. Please take care about those points, those 3 points as a conclusion. Why? Because there are several questions asking about this. When we put the acidic drug in less acidic medium, like the first case, acidic drug with a pKa 5 in less acidic medium with a pH of 7, we get less absorption. But when we put acidic drug, this is the acidic drug, in more acidic medium, what we will get? We'll get more absorption, like in the second case. And if the pH and pK equal each other, the same medium, here we have a 50% absorption. You need to ask about anything regarding to this question? Okay, let us see the next one. Which decrease the tension between solid and liquid? The tension between solid and liquid is called interfacial tension. Interfacial tension. This interfacial tension, which is the force per unit length that acts along the interface between the two phases, the solid and liquid. The interfacial tension depends on the cohesive forces within each phase and the adhesive force between the phases. The choices here either is it solubilizing agent, wetting agent, hydrophilic agents, or emulsifying agents. The right answer is wetting agent. Wetting agents, not emulsifying agents. Why we called it wetting agent, not emulsifying agent? Because here the two phases, one of them is solid and the other is liquid. In this case, we called it wetting, not emulsifying. While if the two phases, one of them is liquid and the other is liquid, but they are invisible to each other, in this case, we called it emulsifying agent or surfactant. Okay, is it clear? This means that when the solid and liquid are the two phases, we called it wetting agent. While when the two phases are similar, liquid and liquid, but they are invisible to each other, we call either surfactant or emulsifying agent. The next one. Normal rectal temperature is usually measurable in the evening or about the same as the normal oral temperature or about 1 degree lower, 1 degree higher. The rectal temperature is 1 degree higher than oral temperature. And this was present in one of the previous exams. Please pay your attention with me in this question. This is an important calculation. Sorry. Approximately 50% of fluoxetillin is excreted unchanged in the urine. What is the meaning of this expression? when they mention that any drug excreted unchanged in the urine, this means that the kidney does not affect the excretion of this percentage. Okay, or by another statement, this drug or this percentage of the drug does not affected by the kidney status. Either the kidney is fully functioned or having a problem or impaired kidney, this percentage of the drug does not affected by the kidney, excreted whatever the kidney status. Okay? By this statement, the 50% of cloxacillin is excreted unchanged. This means that if the dose is 100 milligrams of cloxacillin, 50 milligrams will excreted. Either the kidney is fully functioned or zero function. Okay? But the remaining percentage, the other 50%, affected by the kidney status. Let us read the question. If the normal dosage schedule for cloxacillin is 125 milligram every 6 hours, a patient with renal function of 20% receive which dose? What is the dose in this case? Okay. Let us see how can we solve. Yes, it is 75, but how can we get this percentage? When the kidney having 100% of its efficacy or its function, the excretion of the drug from the kidney was 50%. Okay, plus another 50% without kidney effect. When the kidney becomes 20% of its function, what is the percentage of excretion of this 50%? It will be 20 multiplied by 50 over 100. Okay, 20 multiplied by 50 over 100 equal 10%. So 10% only of this 50% will be excreted. Plus again the 50% which does not affect it. Then the total excretion will be 60% of the drug. Okay, 60% of the drug. This means that we need to give 60% of the dose. The dose was 125 multiplied by 60%, it will be 75 milligram every 6 hours. Is it clear? This is how can we solve a question like this. All the following are mixed agonist antagonist opioids except the choices: naloxone, nalbuphine, buterphenol, or pentazocine. The only antagonist or pure antagonist is naloxone, while others are mixed agonist antagonists. So we use naloxone in toxicity, while others can be used in treatment of withdrawal symptoms. Many antipsychotic drugs have strong antiemetic effect. This is due to the blockade of which receptor? The antiemetic effect of some antipsychotic drugs due to the blockage of which receptor? Is it muscarinic, serotonin, dopamine, or H1 receptor? It is dopamine receptor. Yes, is C, dopamine receptor. You have a stock solution that contains 10 milligrams of active ingredient per 5 milliliters. So we have 10 milligrams per 5 milliliters. The physician orders a dose of 4 milligrams. How many milliliter of stock solution will be administered? So we need 4 milligrams. Present in how many milliliters? Just by crisscross, you will get the right answer, which is 2 milliliters. It's a very easy calculation problem. Yes, 2. The next one. How many milliequivalents of magnesium are present in 50 milliliter of 20% magnesium sulfate solution? How can we solve a question like this? The first thing is to translate the meaning of 20% of magnesium sulfate. What this means? It means 20 grams present in 100 milliliters. But we need to prepare 50 milliliters. So 50 milliliters containing how many grams of magnesium sulfate? It will contain 10 grams of magnesium sulfate. 10 grams of magnesium sulfate. Okay? Why we convert the unit into milligrams? Because we need to calculate the number of milliequivalents. So milliequivalents, what is the formula of it? It is weight by milligrams over molecular weight, this over the small n, the valency of the positive ion, multiplied by its count. The positive ion here is the magnesium. Its valency is 2. How many magnesium ions in that molecule? Only 1. So the small n here equal 2. Making this formula, many equivalents equal weight over molecular weight over the n equal 10,000 milligrams over the molecular weight that we given over the 2, it will be 81.3. 81.3. Okay? What happens when you take a parenteral preparation that's not isotonic? Not isotonic means we have two possibilities. It may be hypertonic or hypotonic. Let us understand the concept firstly. The concept here, when we have two solutions separated by semi-permeable membrane like this, the right one having a very high concentration or a very high number of particles, while the other one, the left one, having low number of particles or low concentration. What is the direction of the fluids? From which side to the other side? From the right to left or from left to right? The flowability of the fluids will be from the lower concentration side to the higher concentration side. Why? In order to decrease the higher concentration and make the both sides having the same concentration. This is why, to decrease the osmotic pressure between the two liquids. So the direction of flow is here from the left to the right. Okay. When we compare the left to the right, it is hypotonic to the right. While the right to the left, it is hypertonic. What about isotonic? Both of them having the similar concentration. So we call them isotonic. And the flowability is the same. So that the net result is no flowability from one side to another. Here, when the patient taking a parenteral preparation, which is not isotonic, if it is hypertonic, what will happen? Hypertonic means it contains higher concentration. The direction of fluids from the RBCs to the fluid or to the hypertonic solution. Therefore, shrinkage of RBCs will happen. Okay? While if we inject hypotonic solution, the fluids will transfer from this solution into the RBCs, leading to swelling of RBCs. Then rupture. They will swell, then rupture, or hemorrhage will happen. So, what is the right answer? Hemolysis of RBCs? Yes, this is the right answer. Okay, this is the right answer for this question. Please, if you have a problem with this concept, ask about it because it is an important one and they ask about it several times. The next one. Another question about isotonicity, but with a calculation. Isotonic sodium chloride 0.9% contains what? 0.9%, you should know what is the meaning of 0.9%. It is 0.9 grams present in 100 milliliters. So every 9 grams present in 1000 milliliter or 1 liter. Okay. This means that number of millimoles of sodium chloride here equal weight by milligrams over the molecular weight which is given. Okay, so it would be approximately 150 millimoles per liter of sodium. Memorize this number very well. If you have a question like this, directly choose 150 millimole per liter. And this question repeated several times previously. The following chemical structure is the type of essential fatty acids. And the bond between the carbon number 3 and carbon number 4 is essential for its omega activity. This is a fatty acid. Carboxylic acid, carboxylic group with a long chain hydrocarbon. So we call it fatty acid. Okay. For knowing the omega system, we should start the numbering from the other side of carboxylic group. So this will take number 1, 2, 3, 4, 5, 6, 7. Okay. While for IUPAC nomenclature, we should start from this side. This carbon will take number 1, 2, 3, 4, and so on. Okay. We have here 18 carbons. 18 carbons. For omega system, we should see the first double bond at which carbon is present. The first double bond here present in the carbon number 3 or in between carbon number 3 and carbon number 4. So we called it omega 3. This fatty acid is an omega 3. Which of them? Linolenic acid, linoleic acid, docosahexanoic acid, or icosapentanoic acid?
A.
A. Linolenic acid, while others are omega 6. And the omega 9 is oleic acid. Oleic acid is omega 9. Means that the first double bond in between carbon number 9 and carbon number 10. Okay. So those are the essential fatty acids. Linolenic is the omega 3. Linoleic is the omega 6, while omega 9 is called oleic acid. The next one. About this structure, the following drug described as. Okay, how can we know the structure? Is it diuretic or antidiabetic agents or laxative or muscle relaxant?
B.
Antidiabetic agents, sulfonyl urea. The main part of this structure here, this is the urea structure. C double bond O and attach it to two N atoms. This is the urea. So we have here urea. And this one is a sulfonamide structure. So we have a sulfonide urea. Sulfonide urea, they are antidiabetic agents. Wernicke-Roscoff syndrome resulted from which of the following deficiencies? What is this Wernicke-Roscoff syndrome? It is a deficiency of vitamin B1, which called riboflavin or thiamine or folic acid or ascorbic acid. It is thiamine. Okay, thiamine is a vitamin B1. Riboflavin is a vitamin B2. Vitamin B3 is a niacin or nicotinic acid. Okay. The folic acid is a vitamin B9, while ascorbic acid is the vitamin C. The last question today. Hemolytic anemia may be resulted from the treatment with which of the following? Hemolytic anemia happens by two main causes or two main reasons. Either genetically or due to deficiency of a specific enzyme, which called glucose 6-phosphate dehydrogenase enzyme. This enzyme is an important enzyme in our body which prevents the hemolysis of the blood. If this enzyme not present or having a deficiency, the RBCs will having a hemolysis. We have a hemolytic anemia. Some drugs leads to deficiency of this enzyme, so they will lead to hemolytic anemia. Like what? Let us see the choices here. Doxycycline, clonidine, methyl dopa, or amlodipine. Methyl dopa, one of the main drugs that may lead to hemolytic anemia due to the deficiency of glucose 6-phosphate dehydrogenase enzyme. Other drugs, like what? Cephalosporins, levodopa. Okay, those also may lead to deficiency of glucose 6-phosphate dehydrogenase enzyme, which may lead to hemolytic anemia. This was the last question today. Still, we have other lectures in our revision. So if you want to join the full revision, you can join from the website, from our website, from the following link, uptech.com course exam of K, or you can contact directly with me in WhatsApp number. This is the WhatsApp Now we can open the discussion, and if you have any question about what we discussed today, you can ask about it. No, any questions?
Sorry,
Yes,
sir. I
please.
do have a question. Can you
Yes, please.
go back to question number 15? Just the first part of the question: isotonic and hypertonic and hypertonic. Hypertonic. Sorry,
Question number 15. The first
15.
part.
Yeah.
What is your question here, or what do you want to hear?
How the concentration go to the left to the right?
Okay. From the left to right, which will transfer? The particles or the fluid? The fluid will transfer from the left to the right. Why? In order to make both concentrations similar to each other. This is why, in order to decrease the osmotic pressure over this membrane. Here we have a high osmotic pressure. Why? The high osmotic pressure due to the higher concentration of the right side. To decrease this higher osmotic pressure, we need to decrease the concentration of the right side by the transfer of the fluid from the left to the right to make the right side more diluted and decrease this osmotic pressure. This is how the fluids transmit from one side to another side. Okay, so when we compare the left to the right, the left is a hypotonic in comparison to the right, while the right is a hypertonic in comparison to the left. Okay, is this your question?
Yes, sir. It's correct. Yeah, I got it. Thank you.
Samantha asking about the question number 1 again. Let's go back to question number 1. It is a calculation problem. Here, it's a very easy calculation problem, just knowing the meaning of the 10-drop set. What is the meaning of 10-drop set? It means a dropper provides 10 drops per each 1 milliliter. So if you want to drop 1 milliliter, you should drop 10 drops. Okay? Here he gives us the rate of infusion per 30 minutes. 75 milliliter of the infusion over 30 minutes. And we need to calculate number of drops per minute to give this infusion rate. How can we know that? Firstly, you should know how many milliliter injected per minute, per 1 minute. It is 2.5 milliliter per 1 minute. This 2.5 milliliter, from how many drops we can this 2.5 milliliter? Every 10 drops will give us 1 milliliter. So the 2.5 milliliter, we can obtain it from 25 drops. So every 1 minute, you should inject 25 drops from this drop. Okay, is it clear? As I mentioned, still we have another revisions. So you can join the full revision, which contain a lot of questions from the previous exams, especially the last one. Okay, don't miss this revision in order to pass your exam very easily. The coming one will be one of the full revisions related to the paper number 2 in the coming Saturday. Thank you so much for your attendance today. I hope it was a useful and easy lecture for all of you, and see you in the coming revision.